right, I mentioned in the last video of the systems of equation in 3 variables that we tend to like to use matrices for solving them, and you're probably like, but I don't know how. That's what this section is all about. So a matrix, if I have a systems of equation here, now notice this is 2 equations, 2 unknowns, but we can have 3. We call it, typically this is a 2 by 2, we can have 3 by 3. And notice how we write it in a matrix, that the coefficients are written and then a line is written for the equal sign. So this is moving from our equation with the variables to this matrix. And these matrices, so a rectangle array of numbers like the one above, which was the previous one here, is called a matrix, plural matrices. The matrix is an augmented matrix for the given systems of equation because it contains not only the coefficients but the constants. This first piece is the coefficient matrix. So if we look back here, that's this piece right here, and then with our constants. The row of a matrix are horizontal, and as you can see, each row is an equation. The columns are vertical, and each column was a variable and then our constant. A matrix with m rows and 2 columns is said to be order m by n. And if m equals n, the matrix is said to be square. So just looking at the coefficient matrix, 2 rows, 2 columns, that is definitely a square matrix. You're going to learn how to go through this Gaussian elimination with matrices. You're going to see a lot of row operations. Again, this is just preview of what's to come, but we will work through a lot of these together. We like to get this in what's called row echelon form, and this just kind of explains what it looks like, but this is what your matrix, you're trying to get it in this form, because if you think about it, if each one of these columns is a variable, so I have eliminated the first 2 variables, now I could use back substitution because I have what one variable equals the value, so that's like 1z equals this value, and then I can use back substitution. We want to make sure that we really understand this row echelon form. Notice the ones down the diagonal. So this is definitely not row echelon form. And again, if you know the last equation, the one variable, you can use back substitution. What we really like to get to, but it is a lot more steps, as you will see with the row operations, is the reduced echelon form. Because once you get your coefficients in this form, then you will see after the line, let's say these are x, y, z variables. X is going to equal that number, y will equal that number, and z will equal this number. Don't worry, we will do a lot of these in the homework to get some practice getting through the row operations.